Hello everyone, Soryura here. In part 3, we looked at how to easily swap out sound from the outside, right? And I mentioned we'd look at how to handle sounds inside the MetaSound next. But hold on a second. What we just made are ambient sounds. Usually, in games, the ambience changes depending on the zone. For instance, that way is a cave and over there is a forest, so if we just think, I'll make an actor and just drop it right there, what happens? Yep, you get 3 different sounds playing all at once. That's because, in our blueprint, we use the begin play node to trigger the sound the moment the game starts. So, today, we're gonna learn about something called box collision. First, let's open up the actor we made. Go to top left, click add, search for box, and click on box collision. See the little box? Let's scale it up, set the X, Y, and Z scale to 10 each. To put it simply, a collision is like an invisible sensor. When a character or an object in the game touches this invisible box, it detects it. Next, let's head over to the event graph. Out of the nodes we already have, leave only the Set Wave Parameter node and delete everything else. Then, right-click and create an Event Actor Begin Overlap node. Think of this as a switch that flips the very first moment something touches our invisible sensor. Now, we only want it to detect our player, right? To specify that, we are going to bring in the node called getPlayerPawn. This node is a command that says, out of all the pawns on the map, grab the exact one we are controlling, player index 0. If you put a different number in there, it will detect the player corresponding to that specific index. Next, we're gonna create a branch node. It literally means a branch on a tree, but in Unreal Engine, it acts like a strict bouncer. If a condition is met, it lets the signal pass through the true path. If not, it blocks it via the false path. After that, drag out from the other actor pin on the overlap node, search for double equal sign and create an equal node. Then, connect our getPlayerPawn into this equal node as well. What exactly are we doing here? We are taking the other actor, the thing that just bumped into our sensor, and our getPlayerPawn, putting them side by side and asking, hey, are you two the exact same guy? Then, if we connect the lead line from the equal node into the branch, it necessarily means, is the object touching the box collision our player character? If yes, I'll send the signal out the true pin, so give me the next command. Alright, so our command is going to be play the sound when we overlap. But having a sound just suddenly pop in feels pretty unnatural. So let's use a fade in node to smooth it out. Now pay attention here because this is a crucial point. This fade in node absolutely has to come before the Set Wave Parameter node. Why? Because we need the fade in to actually start the audio component and get the engine running first. Once it's running, we can inject our audio data in real time. That's the only way it's going to play correctly. Let's disconnect the audio component from the Set Wave Parameter for a second and hook it up right here. Let's tidy up these wires so they look nice and clean. Just double click the wire to make a reroute node and drag it around holding Ctrl and left click. Set your fade in time and right after that, let's attach a print string node. This is an awesome debugging tool that pops a little message on the top left on the screen, just so we can visually confirm everything is working. Okay, we've set up the logic for working into the zone, but we aren't done yet. If we don't tell the game to turn it off when we leave, that sound is just gonna keep playing forever. So this time, let's bring out the event actor and overlap node and we'll connect it the exact same way as before. Since we are leaving the zone, there are no need to swap the sound out again. That means we can just skip the Set Wave Parameter node here. Instead, just connect it straight into the fade out node and set your fade out time. Alright, let's hit play. By the way, when you first hit play, you might be standing right inside the zone, but you won't hear the thing. Any guesses why? It's because the system is waiting to detect a collision. You didn't actually work into it, you just spawned inside it. So, if you walk outside the zone, see that? The text pops up to say we left. Now, let's walk back in. Hear that? The sounds naturally phase in and then phase right out when we leave. Perfect. So, what's left? You just take this actor we made, copy and paste it around your map, and drop your specific sounds into each one. That's it. It's also a good idea to change the print string text for each zone so you don't get confused later. But today, we're gonna take it one step further. Hearing the exact same ambient loop over and over gets pretty boring, right? Let's make it so 3 different sounds play randomly. Head back into the blueprint and let's rename our variables so it's clear. Don't worry, changing the name won't break anything right now. Next, click the variable type icon and change it from single to array. When you change it to an array, you will get a little error on the wire connected to the Set Wave Parameter. Just ignore it and break the connection. Now, drag a wire out from your array variable, create a random getItem node, and plug that straight back into the Set Wave Parameter. This node is really useful. It simply looks into our array and picks one item at random. And go to your array variables details panel, click the plus button, and add 3 slots for our sounds. If you go back to the viewport, you'll see the renamed variable and 3 empty slots. Fill those with 3 sounds of your choice. Now, every time you enter that zone, one of them will play randomly. If you copy and paste this across your map and assign different sound, you'll get a unique, randomized ambience in every zone. Thanks for watching today. In the next video, we'll look at some internal MetaSound settings and how to manage all of this systematically using data tables. That's it for me. See you next time.